So in this video we're going to continue to look at Pythagoras Theorem. If you haven't already, it's important that you make sure to watch the first video on Pythagoras Theorem and how to work out both the hypotenuse and a shorter side within a right angle triangle. So in this video we're going to look at these types of questions where we mightn't specifically be dealing with straightforward questions involving right angle triangles. Rather, what we have to do here is identify a right angle triangle within the shape, or in the case of a worded question, visualize where we would have a right angle triangle present. So we'll get stuck into the examples. In this first example here, we're not actually dealing with a right angle triangle, we're dealing with a rectangle. So we've been asked to find the length AC. So we have a rectangle here that's labeled A, B, C, D, okay? So the distance AC is the distance between A and C, so corners A and C. So this distance here, this slanted distance here. Okay, so when we're dealing with a rectangle, and we've been given the sides of the rectangle, and what's important also to remember is that opposite sides are the same. So if this side is 7, this side is also 7. If this side is 4, over here is also 4. And it doesn't actually matter when we split the rectangle like this. We've got two right angle triangles, okay? So we've got this ADC or ABC. It doesn't really matter which one we use. So just what I'm going to do is I'm going to use triangle ABC, okay? So just marking it out with red here just to show you. And what we can do now is actually ignore the rest of the shape. So there is our right angle triangle, okay? And that side on the left, because it's a rectangle, originally we know that that is also 4 centimeters, okay? So once we've identified the right angle triangle, we just follow the steps that we learned in the previous video. So identify the hypotenuse. So the hypotenuse is facing the right angle. The right angle in our right angle triangle is here, and it's pointing, telling us that this side AC that we're trying to find is the hypotenuse. So that means we're adding later in the question. We now follow the rest of the steps. Okay, so the steps start off with squaring the known sides. So we square 4 and we square 7. So 4 squared and 7 squared. 4 squared is 16. 7 squared is 49. 49 plus 16 is 65. Okay. And we know that we're adding because, again, as I pointed out earlier, we're trying to find the hypotenuse. And the last step is to always square root. Okay? So, using our calculator, it's not a square number, so we square root 65. Round to a suitable degree of accuracy when we have to deal with an answer of this nature. Okay, so I'm going to round to 1 decimal place here. So it's 8.1 because the 6 dictates that we round this here up to 1. Okay, so 8.1 centimeters. Okay, and that's it. Once we've identified the right angle triangle in these questions, it's straightforward Pythagoras Theorem. Okay, now in the second question, we're not actually dealing with a right angle triangle, we're dealing with an isosceles triangle. We're asked to find the perpendicular height of the shape. So the perpendicular height of a shape is the height from top to bottom, its tallest point. Okay, so in this case, if we can visualize, it's straight down the middle of the shape here. Okay, and a perpendicular height, it says it in the name, it's perpendicular to the base. The perpendicular height means that we split this shape in two. We know it's isosceles by the fact that these two sides are marked with these lines indicating two sides are the same. When two sides are the same within a triangle, that tells us it's an isosceles triangle. So here is our right angle triangle. Again, it doesn't matter if I was to use the other half of the shape because if this 6, this side is also 6. Okay, both triangles are mirror images of each other in this case. So in red, I have my right angle triangle. After that, we've identified our right angle triangle. It's straightforward Pythagoras Theorem. Okay, the side across my right angle is our hypotenuse. So we know our hypotenuse is 6. Now, when we're dealing with an isosceles triangle, this is important. If the bottom of the overall isosceles triangle is 8, we're only dealing with half of that. So we're only interested in distance from here to here. And we know that that is half of the overall isosceles triangle, so therefore that is 4 centimeters. Okay, so we're trying to find this side here, this perpendicular height of the overall isosceles triangle. Therefore, we're finding the shorter side of our right angle triangle. So what we're doing in this case is we're actually subtracting. So we'll follow our steps that we learned in the previous video. We square both sides, 6 squared and 4 squared. Again, making sure we're using 4, half the overall size of the isosceles triangle. 6 squared is 36, 4 squared is 16. Because we're finding the shorter side, we subtract. 36 take away 16 is 20. Square root of 20, again, it's not a square number, so we make sure to use our calculator. Square root of 20 is 4.47, etc. So rounding to a suitable degree of accuracy, 4.47 becomes 4.5. The 7 dictates that we round this up to a 5. Okay, so 4.5, and again, we're working with centimeters here. All right, now the next example we're going to look at is a worded example where we actually don't have a diagram to work from, and it's a very commonly asked question where we have a ladder resting against the wall. So I'll read out the question. A ladder 3 meters long rests against the wall that is 2 meters in height. Find the distance of the bottom of the ladder from the wall. So if we were to try visualize that, it's perfectly fine to draw a diagram to help yourself imagine that. Okay, so here's my ladder. If I imagine I have a 3 meter ladder sitting at a slant, the wall is 2 meters tall, so from top to bottom. And if you always remember that a wall should be at a right angle to the ground, we're actually finding this distance here between the bottom of the ladder and the ground, and there is our right angle in here. Okay, we know the ladder is 3 meters long. So in the case of this triangle, if we start off again by identifying our hypotenuse, which is opposite the right angle, we know the hypotenuse, so therefore within this triangle, the side we're trying to find is actually a shorter side. We now follow our steps of Pythagoras Theorem. So we square both sides, 3 squared and 2 squared. 3 squared is 9, 2 squared is 4. Find the shorter side, so we subtract. 9 take away 4 is 5. And the last step is, of course, to square root. 5 is not a square number, so again, using our calculator, square root of 5 is 2.23, etc. So 2.2 is what we're rounding to a suitable degree of accuracy, 1 decimal place, 2.2. And our units for this question is meters. Now, I could go on and I could do countless examples of this nature. So ladders against walls, we could have coordinates on a coordinate grid. I'll give you a couple of different types of questions to try, whether worded questions may be asked in context of a real life scenario. Always the same thing, identifying the right angle triangle and then using Pythagoras Theorem from there. I'll also in future videos look at Pythagoras Theorem in 3D shapes, as well as moving on to trigonometry as well, which is the next topic in relation to our right angle triangles. So have a go at the questions, and if there's any issues, just ask.